Welcome on board. This video is part of a training course by the Sea Nation Sailing School. In this video, we'll understand one of the most important and oldest foundations of marine navigation, the magnetic compass. You will learn how the nautical compass works, what bearings are, including magnetic and relative bearings, how bearings help in collision avoidance, the difference between true north and magnetic north, what magnetic variation and compass deviation are, and how to apply the TVMDC rule correctly. Chapter 1. Compass. Let's begin with the magnetic compass. Magnetic compass works using Earth's magnetic field. It is a simple navigational tool, and yet very reliable. Inside a nautical compass, a card is marked from 0 to 360 degrees, floats in a liquid, and pivots on a point at center. The magnets in the card align the card with magnetic north, and that's how direction is shown. The liquid in compass is required to stabilize it against motion at sea. It is generally a mixture of distilled water and ethanol in equal proportions. Ethanol works as antifreeze. Directions are expressed in cardinal points, that is, north, south, east, and west, degrees from 0 degrees to 360 degrees, compass points, northeast, southeast, southwest, northwest, and also secondary intercardinal points. These points are halfway between cardinal and ordinal points. Now, let's understand what is a bearing. A bearing is the direction of an object from your own vessel. True bearing is measured from true north, while magnetic bearing is measured from magnetic north. Relative bearing is measured from ship's head. The most convenient device for measuring bearings is a handheld bearing compass. Let us assume a lighthouse is at 090 degrees. That means it lies exactly to the east of your vessel relative to the magnetic north. To observe magnetic bearing using your compass, align the vessel or the object on the azimuth mirror and rotate it till you see it in the center line. You can read a value in 3 digits on the card of compass below it. That 3-digit figure is the magnetic bearing of compass. Relative bearing is measured as an angle from your own vessel's heading. Your heading is always 0 degrees. Right ahead, a beam on port or starboard, and right astern. It can also be measured in degrees, port and starboard. Whenever another vessel is spotted, the first thing you do is lock your eyes on a fixed point of that vessel. It could be the bow, or at night, the masthead light. Now, without wasting time, take at least 3 bearings, roughly 2 to 3 minutes apart, using your hand bearing compass. Record the bearings. Write down each bearing to observe the bearing drift, that is, how the bearing changes over the time. If the bearing remains the same, example 020, 021, 020, that means there is a high risk of collision. A change of 5 degrees or more between readings indicates a lower risk of collision. If the bearing increases, example 075, 080, 085, that means the vessel will likely pass astern of you or on your starboard side. If the bearing decreases, example 047, 040, 033, the vessel will likely pass ahead of you. Continue taking bearings until the vessel is well clear, as collision risks can change. The north to which your magnetic compass points is not the true geographical north. It is called magnetic north. Magnetic north lies somewhere near to geographical north, but its position keeps shifting. In recent decades, it's actually picked up the pace, sprinting from Canada towards Siberia at about 55 kilometers per year. Deep beneath our feet, about 3,000 kilometers down, lies the Earth's outer core. This is a sea of molten iron and nickel. Because the Earth rotates and the core is incredibly hot, this liquid metal is constantly churning in convection currents, much like boiling water on a stove. Since molten iron conducts electricity, its movement creates electric currents, which in turn generate our magnetic field. As for true north, it is the point where the Earth's axis of rotation meets the surface. If you put a giant skewer through the Earth and spun it, the 2 points where the skewer exits are the true north and south poles. That is why it is static. True north is a fixed geographic point. Magnetic north is where your compass points. The angle between them is called variation. This value depends on your location and is shown on nautical charts inside the compass rose. It is measured east or west. Here we can see the variation. In the year 2020, in this specific area of the map, magnetic north was 10 degrees east of the true north. The value in parentheses indicates the annual change, which is 30 minutes east. From here, we simply multiply this annual change by the number of years passed since the year 2020, and add the result to the original 10 degrees. This will give us the current variation for this location. One interesting fact is, if you lie somewhere between true and magnetic north, the variation will be 180 degrees. At this variation, you must steer south to go north. Variation is not the only correction on your compass. There is one more error factor called the deviation. The total error in a compass is actually sum of variation and deviation. Deviation is caused by the ship itself. Steel structures, engines, and electronics create magnetic interference. This affects the compass differently depending on the ship's heading. That's why vessel maintains a deviation table as a chart near chart table, which provides correction values for each heading. To obtain a deviation chart, you can hire a certified compass adjuster, which is often required for insurance or commercial compliance. Alternatively, you can create a DIY card by manually comparing your steering compass readings to a hand-bearing compass, a known magnetic bearing, or GPS data. It is important to note deviation is not permanent. It can change whenever major maintenance is carried out, or when equipment is added, removed, or relocated on board. So now we have 2 errors. Remember, variation is an Earth's error. Deviation is a ship's error. To apply these corrections of variation and deviation, we use the TVMDC rule. This basically means on true course, T, apply variation, V, to get magnetic heading, M, and then on magnetic heading, apply deviation, D, to get your compass heading, C. This sequence has to be followed every time. Remember thumb rule, west is best. Add it. East is least. Subtract it. Let's take a practical example. You are required to steer a true course of 0 degrees to travel from one island to another. You check your nautical chart and find variation is 3 degrees west in 2023, increasing at a rate of 10 minutes per year. From 2023 to 2026, that's 3 years. So the total increase is 30 minutes, or 0.5 degrees. Therefore, the updated variation becomes 3.5 degrees west. Now apply this to your true course. True course was 0 degrees. Variation is 3.5 degrees west for year 2026. West is best, so we add. Magnetic course will be 3.5 degrees. Now we move from magnetic to compass. You check the ship's deviation chart for a magnetic heading of approximately 3.5 degrees. Let's say the deviation is 1 degree east. East is least, so we subtract. Therefore, final compass course to steer will be 2.5 degrees. So, to follow a true course of 0 degrees, you must steer 2.5 degrees on the compass. To obtain the true heading from your compass heading, you must apply the rule in the reverse direction. This is how TVMDC is applied in real navigation, step by step, without skipping. Modern ships are equipped with advanced systems such as the gyro compass, which is aligned with true north and based on the principle of gyroscopic stabilization. GPS compasses use satellite signals to determine heading. Both systems are highly accurate, but they are electronic equipment and depend on a constant power supply. We always hope everything works perfectly, and most of the time it does. But when something goes wrong, when systems fail, our most reliable companion remains, the magnetic compass. Simple, independent, and always there. A friend in need is truly a friend indeed.